Hey everybody. So good evening, good afternoon, good night, good morning, depending when you are. We're really excited to talk to everybody today. And we're really excited to be talking about the art of the possible with Crossplane and Shipa. If you're unfamiliar with either or both, don't worry. We'll kind of give an explanation about both of them for you. And also feel free to keep it interactive. If you have any questions, just pop them in the Q&A. If you want to ask any questions, feel free to pop them in the chat. Either Bruno and I or both of us will give you an opinion or an answer. And yeah, really, again, we're really excited to be talking to everybody today. So let's just, come on, go to the slides. There we go. So who are your guys today? So I'm Ravi Lachhman. I'm the field CTO here at Shipa, based out of the East Coast of the United States. And my previous background, I was a chief architect at Harness, worked at a few distributed system firms, not just for Red Hat and IBM, building and crashing a lot of production systems. I was there before blameless culture. I was blamed postmortems, but also my buddies on the call. Bruno, want a little bit of introduction about yourself?
Yeah, Shipa is my second venture. I had an opportunity to do a startup before as well. At Shipa, on the previous startup, I was responsible for making sure the office never ran out of coffee. On Shipa, I'm still figuring out my space, but I try to do a little bit of everything, participate on product, engineering, and sales, and everything in between. And today I'll be working with Ravi to try and give you folks a demo if the demo gods help us today. Let's see how it goes.
I have faith. I have faith. So what are we going to be talking about today? So we're going to be talking about, first of all, let's set the stage. We'll talk about rising engineering complexity, right? So it's like, hey, integrating all these tools are cool, but there's a reason why you want to do that, or a reason what you're trying to fight is engineering burden, engineering complexity. And we'll talk about how that actually occurs. Then we'll be talking about, well, you know what? After there's a march of infrastructure as code, and then we're going to be introducing a concept called AAC, application as code. So how does that evolution or revolution, depending on where you look at it, how does that kind of occur? Where do we come from? Where are we going? And some of the pitfalls and some of the things that you need to create when providing guardrails, et cetera, for your development teams if you're a DevOps engineer. And then finally, we're going to be, if the demo gods shine on us, which they, of course they will, we're going to be showing the art of the possible with Crossplane and Shipa, and Bruno has put together something fantastic for everybody to see. So the first thing is engineering fatigue and complexity, right? Just how many times have you heard just figure it out? Or or in my case, how many times have you felt, oh, I should just be able to figure this out, right? And that's an odd feeling from an engineer to kind of feel that. But what, how do we make that more tangible? So I'll talk about my background. Back in the day, when I came out of university, I was a Java. I started out my career as a J2E engineer, right? So I wrote distributed systems in Java, and primarily I would be writing Java or JMS, and the packaging was easy, right? I would go to a web archive or more, and I would deploy to one of three target systems. So that was pretty much given. It could go to WebSphere, WebLogic, or JBoss. Most of the time, for me, it was JBoss. And that's it. Like, there's a middleware engineer who scales that. I don't have to worry about any infrastructure complexity or application infrastructure complexity or deployment complexity. Like, here's the war, release manager, middleware engineer, do your stuff. Versus today, I'm the same person. I'm older, I'm grayer, I'm bigger, less hair, but overall, I'm still the same person, right? Not only that, the language has more granularity and more, let's say, share in the language. So there's front end stuff, back end stuff. Looking at this like kaleidoscope or eye chart of icons here, it's what a typical, let's say, full lifecycle engineer has to do with. We have to deal with the going left to right, deal with the open source, deal with writing the feature. We have to automate the build. We have to automate the infrastructure. Are we going to Docker? Do we use this whale here? For us, we're pretty heavily invested in Kubernetes, so we have to create Helm packaging, for the package management and customize for the configuration management. And then we also have to make decisions on the observability frameworks. We get to get a Prometheus aggregator. We use StatsD and Fluentd. And for most of the stuff, we deploy in GCP and AWS, which, if you heard the beginning part of the call, like when Bruno and I were talking about, we were running into IAM issues with GCP earlier. And so there's a lot of complexity out there, right? And who owns all of this? Talking about, where on earth, who owns this little puzzle to kind of get across? Does a system engineer own all that? Is someone who's operationally focused on that? Does the developer, if you're a developer, do you own all of those configurations and guardrails? Does this DevOps engineer, the person in charge of the development pipeline and efficiency, do they own all of that from soup to nuts? And the answer is probably no. A release engineer, the wanted poster here, if they're still alive or still around. And the answer is there's multiple people who technically should own multiple pieces, but what ends up happening is that with this big effort to shift everything left, right? Like, it actually becomes undue burden to two folks there, the DevOps engineers, and more specifically the developer. And that's what we're here to solve here at Shipa. And so let's talk about a decade ago, how our interactions would have been. And you heard some of our current day interactions before the webinar. But if you take a look at like where, Crossplane's like this, we're starting to march towards like full automation here, like with infrastructure. But if you've been around for a little bit, if you had to develop anything, when I started, everything was static. All of my development resources were static. I have to talk to I keep pigeonholing in this conversation for now. Bruno is a system engineer. I had to go beg the system engineer or write several tickets that, hey, I need in other environments, such as a UAT or a prod environment. Can you add nodes? Can you make load balancer changes? Can you make any sort of web server changes? And that's basically it, right? So we went from static and we're very bespoke. And if we all know that this might be the past or might be current, depending on where you are in the spectrum, but changes took weeks, right? You really had to orchestrate your changes. And this is going back to we were deploying, every quarter, every six months or so. And these type of changes took a long lead time. And there was 3 separate people who did it, right? So the system engineer provisioned the VM. We had to go beg a network engineer to make F5 change. And the middleware engineer would do everything in between, like, provision you node or JBoss. But why is this relevant to the conversation? Is that there's another technology that came out recently. So the mighty Kubernetes, right? So this might be preaching to the choir, but a lot of Kubernetes really is a great equalizer, right? So it allows a lot of people in that particular spectrum to clearly define operational and application-centric tasks. So I know that my application needs to have 2 replicas. It's a scale. Yes, we can write that in a particular manifest here. And Kubernetes being declarative would actually make sure that the state that's written here in this manifest is enforced. And so to the best of its ability and available capacity, it'll schedule work, replace work, and et cetera, all your typical benefits of Kubernetes. And also, this is going to start creeping into, there was code where there was not code before, right? So instead of us or you or me reaching out to a networking engineer to make a load balancer change, you now have Istio, right? So you can make all the Istio routes that you want, Mr. or Mrs. Developer. And this is where complexity starts getting in. Like unfortunately or fortunately for this conversation today, is that my biggest outage was networking. I made a VPC calculation, and I blocked half the internet from our application. As a Java developer, I know the feature, I don't know the networking, but this complexity keeps getting layered and caked on to your development team. A lot of folks that might not have expertise in things like networking, but you kind of look at now the changing roles. Like, so this is playing out a couple of minutes before the call. Was, hey, as a software engineer, let's say even more sophisticated software engineer that, hey, I know we're going to Kubernetes per se, but I wrote a feature that's compliant. I passed all our code coverage tools. I wrote to our enterprise standards, but I'm not a kernel engineer, right? So I'm not dealing with eBPF or those things are beyond me. And I know clearly that our application has traffic coming in and traffic coming out. And then kind of the last piece is the raw reality is that as a software engineer, even as early in my career, it's where the application deployed is implementation detail. Like, it should run somewhere, right? So having to build multiple objects and like having to craft an application specifically to a particular platform, it can get challenging because it takes away from the feature development. And to provide this type of functionality, the poor or the sophisticated platform engineering team or the one-man show in this presentation, Bruno, he has to provide a CI/CD stack. He has to provide a GitOps engine. Has to provide a service mesh. Has to provide a policy engine. Has to provide a cluster management. Has to provide security scanning. Like, there's a lot of non-functional requirements that to get to production that as a software engineer that I had to put up with, right? And every time you change teams, the combination of tools can be very bespoke. So let's talk about the move to infrastructure as code, right? So given that that was the case, so what we're going to be talking about today is Crossplane, right? So this delicious looking popsicle logo here, but Crossplane, it's kind of a two-part tool, right? Or two-part platform, depending on how you look at it. Is that it is a Kubernetes native control plane. And so for integrating things that are not Kubernetes centric, you can reference them as the kubectl commands, right? Or even more so, infrastructure as code. It is a Kubernetes centric way of also managing infrastructure. And part of this presentation, we're actually using Crossplane to spin up another GKE instance to lay down infrastructure to integrate into Shipa. But that's the kind of the power that IAC offers you, right? So kind of the benefits of IAC, preaching to the choir here that, hey, you know what, if you wrap something in infrastructure as code, it's repeatable. So you can call it multiple times. So that boils to the second point there. Things are consistent. And also you have your ability to integrate it, right? So if it's, it's something as code, you can use your CI or CD stack to call something. You can orchestrate it. You can, inject things in a certain part of your development or development pipeline. And that's fantastic, right? But there are a few things that are missing. And this is where the Shipa piece is going to be kind of like filling in some of the gaps. Is that, there's an application platform to it, right? So what typical IAC tools have a slant towards infrastructure or running or managing infrastructure. But what if we were having to build an application platform? So what does that actually mean? Not your company building like a website, right, or a portal for your external customers. What about your internal customers that produce that functionality for your external customers? And so when you take a look at, at software engineer, so I'll personify like platform engineering team, DevOps engineering team, they provide certain platforms and toolings, or this might fall under developer tooling teams. If you work for a big firm, is that as an engineer, I need tools to be efficient and to get my job done. And so there's typically kind of four pillars that an application developer engineer kind of falls into to get their idea into production. One is you need infrastructure, right? Like it's like, hey, you need. I used to make an example like, you'd spark air time to start your car. Everyone has an electric car here now. So that example doesn't work, but you need infrastructure or application infrastructure to start your application. Also, there needs to be a way to educate people about certain policies, right? So it's not a free for all. The quintessential policy is, a developer shouldn't have access to production systems typically, or Kubernetes and production namespace or production cluster. But all of the business controls that we had outside of Kubernetes didn't go away if you were to migrate to Kubernetes. They're just a little bit more difficult to enforce. But coming up with those particular policies, how do we limit usage? How do we limit who has access? How do we limit who inbound and outbound traffic? And really coming up to this core concept is application as code here. How do we define an application in the standard way? Is it 6 Helm charts? Is it a customized file? Is it a combination of that? Is it 90 different manifests? Like what exactly is an application, right? Which can be really difficult. And then, everybody's favorite subject, how do you, get that into your observability stack? How do you report on that? And really coming up with application platform challenges. And so exactly what was defined, what I was talking about in the previous slide was that, DevOps or platform engineering teams or leadership, you have to provide certain things like monitoring, authentication, policies, logging, connectivity information. Like I'm not a networking expert, and also providing those particular pipelines. And for the DevOps teams to be crafting all of this and stringing all this together, for your development teams, is where a lot of interests are today, right? Like there's a huge rise in CI/CD, there's a huge rise in GitOps mindsets. But I'll ask Bruno here. Where has been your biggest, or asking the audience too, like, hey, where would be your biggest challenge in the stack if you had to kind of build something like this? I cheat and say networking because I hate networking, but Bruno, what do you think, your audience?
For me, networking is always a challenge. I'm not a networking person as well. But I would say in general, the problem, at least for me personally, is if you're doing one cluster or 2 clusters, that's fine. But then once you're starting kind of 5, 10, or dozens of clusters, right, or hundreds, like some of the users we talk to, they are doing, then it becomes extremely hard, right? Because then you're managing a myriad of components. Like Prometheus or whatever you choose for monitoring, whatever you choose for authentication, and then logging. So providing a consistent stack of services across multiple clusters and managing these components in a scalable way and being responsible for supporting that and bugs and so on that comes. I think for me personally, that's the biggest challenge, to be honest.
Yeah, absolutely. And one more, I'll cheat. I like to give the class answers. I'm like the worst teacher. I'll tell people the answer. Like, or one really nifty thing that I noticed, like we're pretty fortunate here at Shipa, like we mentioned, to talk to a lot of firms. So we were talking to a restaurant chain yesterday, and we were talking to a major financial, services company. And you would think that, people who sell, meat or chicken would be completely different than someone managing your online banking, but they're very similar into the problems that they walked into. Both of them mentioned that they have different set of users who have different capabilities, which it makes sense, right? It's similar. Like, for example, you might have certain team members who are, certain teams that are on the bleeding edge of Kubernetes, right? We met them at KubeCon, and they're all the TOCs and S and SIGs. But for a bulk share of both of those particular firms, is that they're like, a lot of people don't care. It's hard for us to cater to one set or the other, the power user or the let's say the average or archetype persona at those firms, that it's difficult, because you might go too far, easy, limiting functionality, you might go too far, not providing enough guardrails that people can't learn. It's not very usable or credible in their systems. And so that's a huge, adoption is a huge problem, like for application platforms. Kind of, the rationale before I kind of hand it over to Bruno here in the last minute or so, my part of the conversation is, it's with Kubernetes, you're going to get a lot of manifest, right? And so going back to, it's a technology adoption thing. Like part of it, what I mentioned before, like, oh, yes, let's continue to shift left. Give the software engineers control of the networking stack. That is a simple Istio YAML you found there, Bruno, because there's just a scratching the surface. You have separate objects for routes, separate objects for ingress and egress. Like there could be like a dozen or so of these manifests to even make up one, a service, right? Same thing with, how do we deploy the application? Do we make a rollout? Do we have to make any claims with the rollout? Like it goes deeper, and you start dealing with, how do we template this? How do we give people this functionality? How do we expose it? And, it might be simple for like one person or one team, but if you have dozens of teams or dozens of people, and more so people come and go, right? And people's skill sets go and come, and how do you make that teachable? And this is where Crossplane and Shipa, a match made in engineering nirvana, comes in. So let me hand this over to Bruno now. So if you want to talk a little bit about what folks are going to be seeing from on the demo, then we can show them the goods.
Yeah, so quickly going over that from a demo perspective, when we put the two solutions together, what we want to do is see how we can spin up infrastructure in an automated way, right? And in a descriptive way that we can store the definition in Git, and Crossplane can later make sure that the infrastructure we spin up is true to its desired state. So in case something happens, Crossplane will spin it up. But to have a complete application platform, we also want to enable application policies across that cluster and multiple clusters we have. And we want to show you how to define an application policy at an application level, right? Or define policies at an application level in a way that you don't have to deal with complex rules and API versions and the underlying infrastructure. So a scalable way. And the same way, we want to show you how you can give your developers using that combined platform a way that they can use to define their own applications. If we make it as easy as possible, then we can start enabling a developer self-service type of approach, right? That they get out of that complicated Helm or customized definition, or us as a DevOps engineer having to create and maintain and manage all the time those complicated definitions. Using Shipa and Crossplane, we can give them a very easy definition they can use themselves and expand as new services or new developers when teams come on board. Last but not least, how do we bring visibility, right? A lot of the discussions we have with users, they say that once applications are deployed, developers, they are not really comfortable supporting their own applications because they don't understand the applications and the objects and the relationship to those objects and how they come alive and together. And so we want to give you visibility at the developer level that they can manage and troubleshoot their own application. DevOps and the DevSecOps folks who want to kind of understand what happened to the application, define further policies and so on in audit history. So that's what we're going to be going through from a demo perspective today.
Awesome. I guess it's time to parade to the demo, guys. Let's see.
Exactly. Please be patient with me and be kind. Let me see. I guess you folks can all see my screen at this point. If not, let us know. Let us know if you have any questions as well as we go through. Maybe one, if great, you see it. We're going to be using Crossplane and Shipa. If one or the other is new to you, we're happy to kind of have more detailed conversation, but just to kind of give you some background, we're going to be using a Shipa account to kind of bring this all together. And you can sign up for your Shipa account on apps.shipa.cloud. I just sent it on the chat. So you can sign up for your account. Ideally, what we have here, I'm going to use my drawing board so I can actually justify to my family the investment I did on my tablet, if I didn't break my pen now. So what I have here is I have my Shipa Cloud account. I just created in the address that I sent you folks. What I have created, I have a GKE cluster that I already have running. Let me just bring this up a little bit. In this GKE cluster, what I'm going to be installing is I'm going to be installing Crossplane. And I'm going to be adding the GCP provider for Crossplane and the Shipa provider for Crossplane. So that's the first step that we're going to be doing. I already have a cluster running that I'm going to be using to install Crossplane and install the Shipa provider. We're going to be going through these steps. And later on, every script that I use, we're going to be posting on Git, so you folks can clone, fork, and go crazy with it. So I'm going to be using a cluster called Shipa Webinar. It's already created. Like I mentioned, I'll just connect to this cluster. Let me just make sure I don't have cube file. Great. If I do a get nodes, it should work. It does. Great. If it's too small for you folks to see, let me know. Okay. So the first step for us is to install and configure Crossplane, right? I'm going to be using a very simple instruction that you can find actually here. Let me share this link with you folks. Oops, sorry. Thanks, Robert. I'm going to be using the directions that we have available on this link. If we come here, we have installing Crossplane. What I'm going to do is I'm going to be creating a namespace called Crossplane. And this may be kind of obvious to some folks on the call, but maybe to some other folks who are kind of just evaluating Crossplane or want to learn about it. This is the process that you can go to easily install. And you can script that whole thing, but I'm just kind of doing step by step so you see what's happening. I already have the Helm chart or the Helm repo added for Crossplane. If you don't, you can use these two commands. In my case, since I already have it, I'm just going to be installing Crossplane here. A second, it's installing version 151. It may be their latest version. If I do kubectl, I'll get pods Crossplane system, the namespace that we just created. I see that the pods are initializing at this point. Oh, both are running. Okay, so Crossplane is installed. It was as easy as that. Now what we want to do is we want to install or enable our GCP provider, right? On my GCP provider, what I've done is, let me see here, Crossplane GKE. scripts, env. I created an env file, and in this env file, you can actually list your GCP account. You need a service account, you need an existing project there, and you need that cluster where GKE is already, or that GKE cluster where Crossplane is already installed, right? Now that I have that all together, and you can follow detailed instructions on how from Google on how to create a service account. It's pretty easy. You can do that both from the user interface or from kind of the CLI command. We're going to be installing our, let me see, our provider, right? I have a script here, and I'll post this script on GitHub soon. What this script is doing is it's installing my kubectl, it's running kubectl apply for my provider, my GCP provider that I just mentioned. And it's going to enable that provider for us to be using on Crossplane. So if
it's a similar concept to Terraform. So like if you have a Terraform background, like it's the same thing as saying a Terraform provider is enabling those provider functionalities inside of Crossplane.
Mm-hmm. Exactly. We should have kind of a song on the background when that happens, when it's processing stuff.
Man, you're bold, man. Your stuff comes up really fast. Like, I don't know if it's like the region in like Amazon I use, like things like don't come up as fast.
Oh, but that's just a Crossplane provider. I'm not creating a cluster. The cluster create So if I do kubectl get pods again on my Crossplane system namespace, I see our GCP provider configured there. So what we did so far is we installed Crossplane, and now we just configure GCP, our GCP provider for Crossplane. The GCP provider for Crossplane basically allows Crossplane to connect to your GCP account, so we can create clusters, we can create any other resources that we need. Not only cluster, you can create databases and VMs and a bunch of other stuff as well, manage IAM if I'm not wrong. But we need that provider so Crossplane can connect to our account and do what we tell it to do. Now we're going to be providing or provisioning a GKE cluster in this case. For me to provision a GKE cluster, let me see, I have Crossplane, GKE cluster. You can also create a cluster definition where you are passing the information about the cluster or the master that you want, and definitions around network policy, logging service, and so on. And the node pool configuration, so such as size of the nodes, minimum and maximum nodes that you want, and disk size, and so on and so forth. So these can all be, again, stored in Git, and it can be triggered directly from Git and your pipeline and create your clusters. So what we're showing, why we wanted to show this is because we show that you can define, or in a descriptive way, the infrastructure that you need. And then the next one is how do you actually add an application platform on top of that. So between Crossplane and Shipa, you have the whole thing. Does that make sense? If it doesn't make sense, folks, just feel free to send questions or so on. So I'm gonna do scripts. If I do for, I don't know why I did this, but I have an sh script that actually calls that YAML file and executes that YAML just to make it easier. So everything later can be done entirely. So scripts for create GKE cluster. Great. If I go back to GKE now, I'm going to see it will start creating the cluster for me. But because I don't want to wait, I already have a cluster created here called webcast.dev cluster. So great. Now, if we go back to our drawing board, what we have is we have these two already installed. And what we are doing now is we're spinning up, we're using this to spin up another GKE cluster. This GKE cluster is where our applications are going to be deployed. And for our applications to be deployed, we need to be able to connect Shipa to this cluster. So Shipa will act as our application platform. And going back to Ravi's presentation, we want to make sure that when we lay an application platform on top of our cluster, we already have monitoring, RBAC control policies, and so on, right? So we as DevOps, we don't need to be kind of managing individual components. So how do we get a cluster or application ready cluster as fast as possible so developers can start consuming and we don't need to be supporting a lot from a developer perspective? And because we're creating that through GKE, through Crossplane, if ever this cluster comes down, then later Crossplane will sync that to the desired state and recreate the cluster, re-add the cluster to Shipa, and so on, right? So there's the kind of resource sync that Crossplane brings on board. But we have this cluster here. Now we are going to add this cluster to Shipa using Crossplane. So step one, we created a cluster. Step two, we're going to add that cluster or add Shipa to that cluster, add your application platform to that cluster. If we go back here, what we need to add, the way Shipa connects to a cluster or the way you add Shipa to a cluster is through what we call your policies, right? Your policy framework. That's how Shipa connects to your cluster. And using a policy framework, you as a DevOps engineer or a platform engineer, you can define things such as the scalability of the applications, how much resource the application should you deploy applications deploy using this policy should you use. You can define like simple network policies. So every application deployed pointing to this policy is going to get this network policy. So you can go very detailed or as basic as possible. But using this policy is how Shipa is going to connect to your cluster. So what we're going to do is we're going to use Crossplane to create a policy. And then bind that policy to your cluster. My drawing is pretty bad, but hopefully you folks are going to understand. So what we're going to do now is create that policy, right? Using Crossplane. I have here, to create a policy, a Shipa related policy, and add Shipa to your cluster or bind that policy to your cluster, you need to install the Shipa provider. Sorry, I said we installed it, but it's not there yet. So I'll install it. To install the Shipa provider, it's pretty easy as well, and you can find it here. The first file is going to tell you, basically, it's going to tell Crossplane the image and the information for our Shipa provider. You have the sample of the file here. I already have my file created. So I can do kubectl apply Crossplane provider Shipa. Provider created. The second step is to configure the provider. So tell Crossplane your Shipa token and where Crossplane should reach Shipa at to be able to create and manage the application resources, right? You have a simple file here. As soon as you create your Shipa account, you can use the command Shipa token show, for example, to review your token. And you can use this. I already have that file. So I'm just going to create. And last but not least is just the provider config, right? I also already have that file, but you can copy the content directly from here. So if I run this, great. If I do kubectl get pods, I can see now both the GCP provider and the Shipa provider. So yes, now going back to my drawing board, I have my GCP provider and Shipa installed on Crossplane. Now I want that Crossplane instance to create a Shipa related policy and bind that policy to your cluster. I have a simple policy here. On that policy, I'm calling it CP dev or Crossplane dev, and I'm passing things such as, well, this is the ingress that I want to use for my application. So traffic in this case, you can also use Istio, for example. this is how much applications can scale. The resource plan that you already have created on Shipa, you can use Crossplane as well to create resource plans. So it's limits on how much resources, memory, and CPU and swap your applications can consume. And you can find this all here, available information, which team can use and so on. So I'm creating a basic policy, right? And just reminding you folks that I already have my account on Shipa, and that's how I got my token to connect Crossplane to that Shipa account. And I'll just do kubectl apply policy.yaml. It says it created. Once you sign up for Shipa, you have a Shipa dashboard available to you, right? You have both a Shipa dashboard and you have a Shipa CLI available to you. Looking at the dashboard, if we go under frameworks, that's where our policies are stored. So if we come here, I already see my cpdev policy here. So Crossplane already created that policy. And now what we have to do is bind that policy to my Kubernetes cluster. You have two ways, right? You can bind your policy using the dashboard, which is not kind of scalable in a large in a large scale way or perspective, or you can use Crossplane itself to actually bind that policy to the cluster. So you can go all the way from provisioning the cluster, creating the one or multiple policies, and you can create policies for dev, QA, prod, or different teams or different apps and so on. And you can bind these multiple policies to one or multiple clusters. Because you're using Crossplane in Shipa, you can do it all in a descriptive way that you can store that state in Git. So now what we're going to be doing is, let me see, binding that policy to my cluster. I have a connect cluster here. This is not right because it's from an old cluster. This cluster doesn't exist anymore. Let me just delete this. And I'll create that. I'm going to be using the example from cluster management. It's available here. So I'll copy this. Let's see if I can find. I have so much, actually. So many screens.
I have so many kube configs. Like I cheat and use like Visual Studio Code's like Kubernetes manager to see which actual. I was like, wow, I have like 80 clusters, huh? Like these days.
I just delete and kind of add, so it just makes it easier for me. For Shipa to connect to your cluster, you need to pass three things. One is, or for Crossplane to be able to connect that policy to your cluster, you need to have three things in place. One is the cluster IP. The second one is the CA certificate for that cluster, so Shipa can communicate with that cluster. And the third one is a token. So you need a token for Shipa to be able to communicate. And that token is from a service account that you create on Shipa. You can, again, in the same format, you can use Crossplane to get the cluster address, the certificate, and the token, and you store that in a key management that you have somewhere. In my case, I'll just quickly do that manually so you can see that. Let me connect here. Let me do this because I'm not as organized as Ravi. So I just delete and create things all the time. So following this example here, I'm going to be getting the information that my Crossplane definition needs to be able to connect to that cluster. The first one is my cluster IP. Let me just get this here. There you go. Let me just put that on my definition file. The second one is I'll get the token. And to get the token, as mentioned, you need to create a service account for Shipa, and that service account will be used by Shipa to manage the applications and all the resources. You can find a service account example here that you can use. Again, I already have that file created, so I'll just run it here. It creates a service account, and step number 3 gets us the token for that service account. I know you folks are probably kind of going nuts now. He's showing his service, like his token and all that stuff, but I'll delete this cluster, so no purpose in kind of securing this thing in any way.
They can hit pause on the recording and just watch it
And
line
copy.
by line. Or if they have the new iPhone, they can just like copy it, put text.
Oh, there is that.
Oh, you didn't get the new one, man? Like you take a picture and like you can highlight all the text. Like, gotta get you a new phone, man.
I have the new phone, but I just use it for making calls. And number 4 is going to get us this certificate for Shipa to connect to that cluster. Again, folks, I'm doing this manually, but you folks can probably do this just using Crossplane and automate this whole thing. Okay, here is my account certificate. And if I just put the certificate here, dun, dun, dun. So I'm passing my cluster IP, my certificate, and my token, right? I'm just going to change the name of the cluster here, dev webinar cluster. You can name it whatever. Shipa doesn't need to use the same name as your cluster name. It's better if you do, so you can keep things in order. But it's really up to you. And then the last part that you can see here is the framework. So the policy that you want Crossplane to bind to that cluster. So that's how Shipa is going to be added to your cluster. We created one called cpdev, right? You can add one or multiple policies to the same cluster. And when you create a policy to a cluster, you're going to see that that policy is actually, Shipa is going to create a namespace for that policy. So we have a cp-dev policy that will create a namespace called Shipa-cp-dev. So every policy creates a different namespace, and every application deployed pointing to a policy goes to that specific namespace. So if I go here and then connect cluster, I'll do this. Because this is YAML, I need to kind of do this. I know it's painful. Sorry, I forgot how to do that on Vim VI in my case. I know you got to go in visual mode or whatever, but it's been a long time.
I feel your pain. Like, I'm so bad about lighting up spaces. Like, I have to use a linter that puts little periods for me. So like, I'm like, oh, this is, 5 indents in versus, don't even get me started on, it should have been tabs. Like,
I know how to do tabs, but then if I put tabs, then when I run kubectl apply, it complains because it doesn't want tabs, it wants spaces.
Not YAML friendly, my friend.
I'm not friendly with YAML overall.
Yeah.
Anyone here loves YAML, by the way? Are you a YAML fan?
It was so difficult when I was going. This is like 2018 when I was getting my CKA. Like, just couldn't deal with it. I was like, who invented this language? Oh my God. Give me a data structure. That's what I would say.
We're going to be doing one around using different provider, and a different provider can allow you to use like Python or JavaScript, which is much more familiar to me. That one is good as well. We'll get that. But great. So what we did is we created a policy definition, and now we're going to tell in Crossplane saying, hey, bind that policy to this cluster that we created before, right? So this will automatically add Shipa to that cluster, and we'll come in with authentication, policies, monitoring, and that dashboard, that beautiful dashboard that you saw out there, right? So if I do kubectl apply connect cluster. The connect cluster, no matches for kind cluster inversion. Oh, great. kubectl get pods Crossplane system. Oh, sorry, I'm in the wrong context. Let me switch back. See?
So many clusters.
So many clusters. Let me connect to the right cluster. So I want to make sure that I run this on the cluster where Crossplane is installed with the Shipa provider, right? My mistake, folks. Sorry. Great. Now I hope it works. Yeah. If we go to Shipa now, and we go to events, for example, we can see a new cluster is being added to Shipa at this point. So this is basically this cluster here, right? Crossplane is adding this cluster to Shipa. And because you're using Crossplane, again, it gives you resource reconciliation. If you delete the framework or if you delete the policy will be recreated by Crossplane automatically. And if you delete the cluster, Crossplane will recreate a cluster and recreate the policy in there. So you get this kind of reliable infrastructure that you can use. And because you're using and defining these policies in a very kind of standard and application focused way, if tomorrow you move to GKE 122, or if you move to AKS 120 or whatever, if you change and add more providers, it's the same policy definition. You don't need to be worried about, well, what's the API version? How do I define these things? And how do I install Prometheus on this cluster and anything, right? You get everything in there. So the connection takes a few minutes. Oh, it already did. So I can see my cluster in here. Awesome. So now I created a cluster, I created a policy, and I bound that policy to a cluster, and I have an application platform and dashboard that my developers can use to deploy their applications, and so on and so forth. How do I deploy an application, right? Very quickly, I know we're running close on time. I want to be respectful of your time. I have an app create definition here. You can do kind of all in the same definition, but I just broke it down so you folks can see. This is called CP Bulletin, the app. And the only thing I'm passing here as a developer, this is me as a developer now wearing the hat. I don't know if it's GKE or AKS. I don't know what version. I don't know how policies are made. I don't know anything about Kubernetes. Me as a developer, I just want to deploy my application. And DevOps just want to make sure that whatever is deployed by the developer, Bruno, goes through all the policies applied, right? So I'm pointing here, what's the team that owns the application? So it's the Shipa team, admin team, or whatever team I have access to. And which policy I want to use when deploying this application. So I know as a developer, I no longer see clusters. I see just a policy that I want to use, dev policy prod or project or whatever, right? If I come in here and I say, it's app create, I think. That's right. So if I do kubectl, apply app create YAML, it says application created. And if I go here to the dashboard, I can see bulletin. Ah, it's not here. That's funny. CP bulletin created. Oh, wait, sorry. App create. Framework CP dev. CP dev, yeah. That's interesting. So this definition basically creates an application on Shipa that your team can now use to deploy this to using Shipa, right? As a developer, I'll just replicate it directly from here, but you can create and deploy the applications using definitions that you can find here. So your developers can create and point to a policy. But being quick, I will create in here and just say Crossplane app1, for example. I'll select the policy that I created, CP dev, and I'll select the team that I'm part of. Great. I can see the application directly here. And again, I don't know any Kubernetes as a developer. My goal is to deploy the application. I'll deploy a very simple application. And again, this can be all descriptive directly from Crossplane. I'm just using a Docker kind of public image. And you can do canary deployments. You can expose different ports and so on and so forth. But a very basic one, I'm going to be deploying my application. So what we did is we installed GKE Crossplane, GCP provider, and Shipa provider. We created a cluster. We created a policy. We bound a policy, and it automatically brings an application platform that developers can use. And it comes with monitoring, logging, network policies, and so on and so forth. Still, as a developer, you use kubectl to deploy an application. You're using the crossplane definition. That's a very valid point. You're using the crossplane definition that as a developer, this is what you're passing, right? The name and so on, and you're passing kind of the image. This is much easier for your developer to do than using Helm or Customize. And you on the DevOps side, you don't need to be creating templates for them and managing those templates. Every time there's a new service, you need to create the template. The other thing that you're doing as well is you're giving developers a structured way to see their application. So you can see application is already running. Directly from here, you can find who owns the application, what type of resource plan it's using, the application performance as soon as that there is access to the app, resource consumption. You can see things such as when the application was created, by who, and so on. And you can give your developers as well, or your DevOps, SRE, or DevSecOps team, saying, here's the application the developer deployed. And here are all the objects that Shipa automatically created for these applications and the details for these applications, as well as the services that these applications are communicating with. So now you're providing, or you have a scalable way to implement policies and scale across clusters without managing a myriad of open source components. You're giving your developer a much easier to consume and create themselves definition. And the third is you're giving them a complete platform that kind of they can use to manage the application.
Also, awesome explanation. Like, also, if you want to obfuscate kubectl, you can just stick Flux or Argo in front of Crossplane. And literally, if you want to show that, yours is really eloquent, the one you had in Vim. I unfortunately the app didn't bind, but it's you can just have someone commits that to source code or to their SCM solution, and then your GitOps engine or your CD stack will pick up on it and just apply it for them. So that was how it would look in an actual organization. So
that is right. And we actually have an integration point here with Argo CD that, as Ravi mentioned, the developer can only commit code to Git. And as soon as it merges to master, really depends on how you structure things. Then Argo will pick up these definitions and will apply to the cluster. And anyways, it's still kind of a scalable way for you to manage scale clusters, policies, and give an application portal or use Flux CD, for example. But that's it on my side. I hope that was insightful on how you can go all the way from cluster provisioning to policy and application platforms.
That was awesome. I'm impressed, though. Any last minute questions, friends? It could be anything. Purpose of life. What's for dinner?
It was quick. Yeah, if you're doing it by yourself, you can actually do it much quicker. You can get it up and running, kind of full platform, doing Crossplane and Shipa in really just a few minutes, 10, 15 minutes, you can get it running. It's just because we're going through the process and kind of describing things. But yeah, that's the idea. You're building a quick and scalable model. I hope that helped. That's a good point from Kyle. He's asking about blogs regarding your writing Shipa provider. So everything that we're doing, or Shipa today has all its APIs exposed and available for managing policies, for managing teams, for managing application clusters and everything that it connects to. All the providers that we have, like Terraform, Pulumi, Crossplane, and so on, GitHub Actions, and so on and so forth, they all call these APIs. But that's a good point. We'll put that on my to-do to write kind of how I wrote or how the team created one of these providers, how I wrote or how I can get started writing a provider. But the idea is we have pre-built providers, but you have the capability to extending Shipa into your own providers. And not only extending into providers, but Shipa also gives you event webhooks, for example. So anything that happens to your application, you can connect your applications to external ones, Slack, PagerDuty, and so on. Ravi, I think, recently mentioned or wrote about how to extend Shipa to connect into Teams for Microsoft, but I'll do that as well. I appreciate Kyle. It's pretty good. Thanks, Martin, for the message.
Oh yeah, that was a couple days ago. Just wrote a Teams one just to see how it works. I shot over in the chat just a couple, like, if you're curious about the steps for Crossplane, Bruno had a very eloquent soup to nuts example. If you're lazy like me, I have a lazy example. Then I shot across the webhook, like if you're curious about outgoing webhooks and Shipa, how to manage them.
Yeah, and we got that, and we got one more question saying if we have the Git repo URL. So what we're going to do is we're going to share with you folks the link to the recording after this, as well as I'll upload everything to Git, so you have the examples there, so you can get used. You can use that, but we would love to hear from you. If you're using Crossplane, we'd love to see how you can use Shipa. You can join our Slack channel, and we'd love to work with you on building that application platform and work with you as an extension of your team.
Yeah, awesome. Well, thanks everybody. Really appreciate it.
Appreciate the time today, folks. Now we're 2 minutes, so we're saving 2 minutes for coffee before the next meeting. Thanks, I appreciate it. Have a good day.
Cheers.
Bye.